Hey there, math fans. Let's continue on here. We're going to solve the next collection of problems here. Again, we don't want, if there is a moment of panic when you see these equations, then we need to work on them. Solving should be a calm endeavor. We know at the end that we can check our answer. We know it's a sequence of inverses to get things by itself. And these are of that type. So let's go. Sometimes smoke and mirrors bother people. If something looks different, it bothers them. But you need to identify that the only variable in this first problem is x, and that's what we're solving for. So to me, I'm not easily distracted. If I know what my goal is, I'm going to start working towards there. So I need to get everything to the other side. I don't care that it's inside of a log. This is just a number. I find some students have a hard time with that. There's something about that I've noticed over the years. Like if I say solve x minus 1 is 5, students like that. If I solve x minus the log of 4 equals 5, they don't like it. And in my mind, those are the same. Log of 4 is just a number. For some students, they need me to actually show them that log of 4 is a number. I have to pull it up and I grab a calculator in office hours and I say it's a number. So in place of log of 4, I could put 1.386. And then I say, well, what if I had written 1.386? Would that have been okay? And usually they're like, yeah, that's fine. And so then I'm like, okay, now I'm going to erase it. And I say, what if I put log of 4? Can you do it? And so we need to make that small jump where you don't actually see the number and you can do it. Okay, so anyways, step 1 is we're going to move that to the other side. And this should be a nice, calm endeavor. I know that there are solvers out there that can do all of this, but there's lots of situations where you're going to be manipulating an equation, trying to get a variable by itself. There'll be unknown parameters. So it's not always the case. You can easily do this with a solver. We need to get rid of two things here. This is a power and root question. We need, and if you in your head, you should be thinking, I need to get rid of a cube and I need to get rid of a 1/2. How do I do that? And you can do it in one step. I just wanted to separate. If you had this, you would take the cube root of 2. If you had this, you would square 2. Nowhere in there do I have to take an even root to get rid of it. So we can do all this in one step. All right, here we go. X, why am I switching colors? X equals whatever this is to the 2/3. This is a good example of something that is actually one of the easiest equations to solve on this entire sheet, but tends to be one people get wrong. So anyways, it's going to be, if I was doing this, I might even do it in steps, just because I don't like to put too much in my calculator at once. I find that the more I put in, the more likely I make a typo. So I never go beyond the display, unless sometimes I have to go slightly. But my rule is if you have to go way beyond the display, you should stop. So I'm just going to compute what's on the inside. That's that number, 8.77. I'm going to raise that to the 2/3. Done. Ah, that was lovely. So if I wanted to go back and check my work, I could take that, raise it to the 3/2, and subtract log of 4. So let's raise that number we just got to the 3/2. And I'm just illustrating again how to check to the 3/2 minus log of 4. And that this is where I then gain confidence. Now, in this case, you say, well, you plugged it in and you did not get e squared. And you'd be right. In fact, I looked at it for a second and I was like, uh-oh, our first mistake. Which would be amazing because by now I usually have made many mistakes. Okay, so now I need to see if e squared is the same. E squared, is that the same? And I feel like I also just plugging in, I learn even more about the problem. Yes, it was the same. Done. That's the game we're playing. Let's go over here. So I threw in a few other things. So here is a situation where it appears it's going to be really hard to get x by itself. Why? Because there's two x's. And I don't see an easy way to combine. So this is when these are the challenging problems, not the one on the left. To me, this is not challenging. To me, this is more challenging. Because we have to somehow uncouple the x's so that we can get it together into one x. But we do have a set strategy when there's a fraction, which is to clear the denominator, meaning multiply both sides by x minus 2. And what do we get? Some students need me to show them what this would look like. So that they can see this cancellation. But once you understand the idea of clearing the denominator, you don't need to write that step. So that was not a step that moved me towards my goal of getting x by itself. It was a step that was dealing with an immediate problem. So those are the harder solving problems where you can't see that you're going to just be able to use inverses. You're just crossing your fingers and hoping that they gave you a problem that is nicely solvable. But if it's in the homework, it is. Okay, so now we're going to move from there. I find students do a couple different things, but I think what I'm going to do is expand this out and see if then I can get the x's together. So these problems require a little bit of faith, a little bit of attempt, and now I see it's possible. So now I'm going to get all the x's to the same side. I decided to go that way because I thought if I subtracted the 3x, it was going to be negative. I'm going to add the 6, I get a 7. That's it. For some reason I wrote x, I don't know why. So I'm getting 3.5. If I was going to check my work, I would go all the way back to the beginning. So I would do 3.5 plus 1, all divided by 3.5 minus 2. 3. I know I'm right. So that's how solving should be. I hope I'm illustrating this point. It was only about 10 years ago. I taught for a lot of years before I started emphasizing this checking. But it made me what I started to notice a lot was people didn't understand what their solution meant. By checking, you reconfirm in every single problem that you know what it means. And it removes that anxiety because you know at the end you know you're going to be right. So this is, I think, an important thing for us to be doing. Okay, here I need to get rid of a log base 10. The inverse is the 10th power. There's not that many inverse pairs. This needs to become more and more and more routine. I didn't do the inverse. I saw that I made a mistake there and I was almost going to let it happen. But this case, it's so quick to check, you would just need to plug this in. Log base 10 actually is in my calculator. So we're basically doing log base 10 of 100, which you should already know is 2. Anyways, let's do this one. Again, this one doesn't scare me at all because there's only one x there. I'm going to cube both sides. I'm going to add 1. I'm going to divide by 2. As I said, these are not meant to be stressful situations. It's a celebration of our inverses. So the final answer is 5 to the 1/5. And eventually, if you keep checking your answers, you will realize that you can check them without actually even plugging in a number. So let me illustrate that here. So I would check this answer, but here's how I would check it. I would plug this in here, and I wouldn't even get my calculator out. I would say if I raise that to the 5th power, I'll write it here so you can see what I'm thinking. What I'm thinking is I want to plug this in. But now I know if I raise a 1/5 to the 5th power, it's going to be a 5. And that's going to be a 10 minus 1. And the more you do this, the better you are at it. And that's going to be I made a mistake. It wasn't working out. Good. Finally, my first mistake. I was like, why is this not coming out to be 3? Oh, it's not coming out to be 3 because, and then I went up and looked, and I saw that, well, 3 cubed should have been 27. I was talking and made a mistake there. So that's a perfect example. I was hoping that that would happen eventually. It's bad that I went so far into the problem before I realized this. But that's a full illustration of the whole point I'm making. And I have learned that I try not to polish these videos because I'm lazy, but also because of that. And so the checking, there is a whole celebration of the checking there. Okay, so this is going to be a 14. This is going to end up being a 28 minus 1, and it's the cube root of 27. So you can see I didn't even need my calculator, but I still caught the error. Just the moment of looking up caught my error. All right, success. Let's keep going. What about this one? So I threw in a quadratic. You have 2 approaches. One is that you see if it's possible for you to factor, and that's valuable because if the other side is 0, and you can factor, then you have your answer. Or you do the quadratic formula. Both are good. I usually try to factor for about 10 seconds. I try to come up with numbers that multiply together to give me 2, but the only ones I can think of that are whole numbers are 2 and 1, and those don't add up to 5. So we're not going to do that. So then we're going to do negative 5 plus or minus square root b squared minus 4ac. And I've told my students that when I do the quadratic formula, I usually don't write b squared minus 4ac. I just do that part in my calculator. So I do, and in this case I don't need my calculator, but I'll do it anyways. B squared, which I could have used the square button, I don't know why, minus 8. So I do that immediately. I have found that that just makes it so I have fewer numbers in my calculator. And I've seen a lot of students that when they do that, it really reduces their errors with the quadratic formula. So that's just a practical thing from witnessing students make mistakes over the years. Then you can write down a much simpler thing that's easier to type into your calculator. So then there's 2 answers, the one with the minus and one with the plus. At this point, I probably would do it all in my calculator. Minus 5 minus the square root. And my own personal rule is try not to go beyond the display so you can see what you're doing. So that's about the limit of what I would do. So that's one of my answers. And then we have the other one. Now these ones probably, as I think about it, might be easier to check as a decimal. So I will write this down if we're continuing our little checking thing. And the other one, one thing you can do in this calculator is you can just hit up. You can go over, hit plus. There we go. Negative 0.438447187. Here's one that I really kind of don't want to check. I have this inkling of not wanting to check, so maybe I'll just check one of them. Let's take that number. I'm going to plug it back in. So I'm going to do that number squared plus 5 times second answer plus 2. 0. Okay, that's enough. So here's one that I may have made a mistake. I checked this answer, but I'm going to say that as a good sign. The video is already too long. Okay, this one doesn't scare me at all. So if you think back on the problems we did, the ones we had to do the most work were not these ones with lots of inverses. They were the ones where we had to regroup or do something so we get x by itself. Okay, so here we go. So if your equation is solvable, it's usually because you can do a sequence of inverses to get the variable by itself. And those are enjoyable when you see that. So you can see I don't really think here. I just use my sequence of inverses and then I'm done. There's no anxiety. It's a little celebration of inverses. So here the answer is 1/2 the log of 15. You get this 1.35. This one I can visually check. So you might try the visual check here, meaning I can see when I plug it in, I'm going to get e 2 times 1/2 log of 15. And I already know that's going to be 15 because I can see the 2's cancel, the e's cancel. That's going to be 15. 15 plus 1 is going to be 16. I hit the square root, that's going to be 4. So it's usually easy to check because everything should sort of cancel out. 4 plus 3 is 7. Correct. So I think I will do the challenge problems as a separate video, but I hope that that's interesting. Let me know if this is helping somebody.